Hi everyone, this is Arjay Enseñado and welcome back to my channel, GTR Math Tutorial. So before we start, shout out to my former student in Pagsangan Integrated National High School, to Carla Jane Absalon. So salamat sa pag-share palagi ng mga videos na ina-upload ko sa Facebook. Thank you sa suporta at ingat palagi dyan sa Pagsangan and good luck sa studies. Okay, so ang video lesson natin for today is part 2 of application of Maxima and Minima. So last video nag-discuss tayo ng 1 to 4. So Maxima and Minima for number relation. So this time we have 4 numbers for application of Maxima and Minima for area and perimeter of a rectangle. Okay, so ito yung mga questions. So try nyo munang sagutan bago nyo panoodin yung video. So ito yung numbers 5 to 8. Okay, so ito, panoodin, paki-pause nyo muna. So ayan. Okay, so let's start. So first question. So we have first problem natin. So number 5 na tayo mag-start since meron tayong 4 examples dun sa part 1. So a rectangular field of a given area is to be fenced off along the river bank of a river. If no fence is needed along the river, what is the shape of the rectangle requiring the least amount of fencing? So ano ba yung keyword natin para malaman natin na maxima or minima siya? So ito yon. So question, what is the shape of the rectangle requiring the least amount? So, nandun yung word na least amount. So, therefore, ito ay minimum. So, hinahanap natin ng minimum or minima. So, analyze natin yung problem. Drawing muna natin. So, yun yung first part. Kailangan i-illustrate muna natin. Rectangular field of a given area. So, yun yung given. Wala yung given na area. So, mag-a-assign lang tayo dyan ng variable. So, given area is to be fenced off along the river. So, drawing natin. So, ito, let's say ito yung river. Yung river, meron daw rectangular field. So, ito yung rectangular field. If fence off down natin. So, no fence is needed along the river. So, therefore, assign tayo ng variable. So, x and y na lang. So, let x be the length and y be the width. So, ito y. So, syempre, sa kabila, y din. So, ito, hindi na natin lalagyan ng x dahil wala namang fence dun sa river. So we can have 2 equations here. So first equation is the area equals length times width. So length is x and width is y. So the first equation is a equals xy. So this is our equation number 1. And then equation number 2 is for the perimeter. Since we want to minimize the perimeter. So the question is, what is the shape? So when we say what is the shape of the rectangle, so that means find the dimensions, measure of length and width, requiring the least amount of fencing. So fencing, so that is the perimeter. So the total na distance dun sa yung total na magagamit para sa perimeter natin, para dun sa rectangular field. So therefore, the second equation, perimeter is equals, so just add x and then we have 2y. So x plus 2y, so this is our equation number 2. So we're looking for the value of y and x. So there is no given area. So the area is just this a. So area can be any so constant na number lang yan. So number lang tong a. So let us solve. Okay, so since we have 2 equations, so we want to minimize the perimeter. So express the perimeter in terms of one variable. So let's try to express this in terms of y. So solve for y in equation number 1. So to solve for y in equation number 1, divide both sides by x. So divide both sides by x para ma-cancel out yung x. So therefore, y is equal to a over x. So this is our, so equation number 1. So y is equal to a over x and then substitute the value of y, a over x in equation number 2. So substitute natin yung a over x dito sa y. Therefore, we have p is equal to x plus 2 times a over x. Or so let's just simplify. So just remove the parentheses. So we have x plus 2a over x. Okay, so next step is to minimize. So let us just differentiate with respect to x and then equate to 0, then solve for x. Okay, so since minima problem. So get the derivative, equate to 0, and solve for x. So what is the derivative of x? So we have derivative of p with respect to x is equal to derivative of x with respect to x. So that is 1. Plus, we have a here is constant. So we have derivative of constant over a function. So we can use the quotient rule or the constant over a function of x. So the formula for constant over a function of x is negative of the numerator times derivative of the denominator. So we have negative of the numerator, so we have 2a times derivative of the denominator, derivative of x with respect to x, so that is 1, all over the denominator square. So we have x squared. Okay, so let us just simplify. We have positive and negative. So therefore, the derivative is equal to 1 minus 2a over x squared. Then, equate to 0, solve for x. Solve for x. So, multiply both sides by x squared. Since we have denominator of x squared, so multiply both sides by x squared. So, we have 1 minus 2a over x squared equals 0 times x squared. So, x squared times 1, so we have x squared minus x squared divided by x squared, so this will be cancelled out. So, we have negative 2a equals 0 times x squared is still 0. Then, we can solve for x or solve for a. So, in this problem, since there is no value of a, so a here is just a constant, let's try to solve for a, and then after solving for a, substitute the value of a in equation number 1. Okay? Since a here is, we can solve a in terms of x. So this equation, equation number 1, we have area is equal to xy. So we want to find a relation of x and y. So try natin solve for a, then substitute in the first equation. Because if we solve for x, so parang wala tayong makukuhang relation doon. Magiging value kasi nito, x is equal to plus or minus square root of 2a, then hindi naman natin masasubstitute dito yun sa ano. So kailangan natin ng relation ng x and y. So isosolve natin yung a. So solve for a, so therefore we have put 2a to the other side of the equation by adding 2a to both sides. Add 2a to both sides so that this will be cancelled out. We have x squared equals 0 plus 2a is equal to 2a. Then divide both sides by 2. So therefore, divide both sides by 2. Therefore, a is equal to x squared over 2. Then x squared over 2, substitute in the first equation, a equals xy. Okay, so pwedeng substitute dito, pwede rin dito. So kahit saan dyan, parehas na nakakalabasan niya. So area is equal to x squared over 2 equals xy. Okay, so let us simplify. So multiply both sides by 2. Okay, so multiply both sides by 2. Or we can simply remove x here. So we can divide both sides of the equation. Divide both sides of the equation by x since they both have x squared. Okay? So if we divide both sides by x squared, so this will be, x here will be cancelled out, and then x squared divided by x, so that will become x squared. Okay, so pakita natin para malinaw. X squared over 2, divide daw natin. Divide by x, or that is the same as multiply by 1 over x. The same lang yun, ha? Equals x over y. O sige, multiply din natin 1 over x. Dividing by x or multiplying by 1 over x, that's the same. So, we have xy times 1 over x, so we can cancel out x. So, the remaining term is y. Then for this, we have x squared divided by x, so we can cancel out x and then cancel out 1x in the numerator. So, therefore, we have 1 half x. So this is the shape of the rectangle. So this means y is the width. So the width should be 1 half of the length. Okay, so width is, so therefore to minimize the fence that is needed. So therefore the width should be 1 half of the length. Okay? So that's the answer. Y equals 1 half of x, or width should be 1 half of the length. Since the question is, what is the shape of the rectangle? So the shape of the rectangle, to minimize, ayan, requiring the least amount of fencing, so the width should be 1 half of the length. Or so in equation, y is equal to 1 half of x. Okay, so this should be the shape of the rectangle to minimize the fence. Okay, so next example. Okay, number 6. So a rectangular lot is to be fenced off along a highway. If the fence on the highway costs $3 per yard, on the other sides $2 per yard, find the area of the largest lot that can be fenced off for $100. So ang mina-maximize natin dito is find the area of the largest lot. So we want to maximize the area that can be fenced off for $100. So the budget for the fence is $100. So we want to maximize the area. So therefore we have two equations. So again, the cost or the perimeter, then from the perimeter we can derive the formula for the cost, and then we want to maximize the area. So let us draw first the figure. So rectangular lot is to be fenced off along a highway. So let's say this is the highway. So yeah, so this is the highway. So this is the rectangular field. So yung sa side ng highway is $2, $3 ang cost, and then this is the rectangular field. Okay? So on this side, the cost is $3, and then on the other sides, on the three sides, so the cost is $2. So let's say this is y, this is also y, and then this is x and x. So the cost along the highway is $3, and then the cost for the three sides is only $2. So we have $2 here, $2, and then $2. Okay, so the formula for perimeter of a rectangle is equal to 2x plus 2y. So but we have the cost is we have given cost for $100. So how can we maximize the area given the budget is only $100? So from this formula, so we're going to multiply the side by the cost. Okay? So the formula now, our first equation for the cost is equal to, so given the cost is $100, so we have $100 equals, so multiply this to, so this is $3 for the side on the highway. So we have 3 times y, plus we have 2 times, or we can multiply 2 and x, so we have 2x plus another 2x plus 2y. Then let us simplify. So we have 100 equals, combine like terms, so we have 3y plus 2y, we have 5y plus 2x plus 2x, so that is equal to 4x. Okay, so this is our equation number 1. Then for equation number 2, we want to maximize the area. So we want to maximize the area equals xy. So ito yung equation number 2. So now, we're going to express the area in terms of x only or y only. Using this equation, 100 equals 5y plus 4x. So let us solve for y so that we can express area in terms of x only. Okay, solve for y in this equation. Okay. Okay, solve for y in this equation, then substitute in this equation number 2. So we have 100 equals 5y plus 4x. So solve for y, subtract both sides by 4x. So we must isolate y. So minus 4x. So therefore this will be 0. So we have 100 minus 4x equals 5y. Then divide both sides by 5. Divide both sides by 5. So that the right side will become y only, and then just divide this by, divide the numerator by 5. So 100 divided by 5, that is equal to 20 minus 4 divided by 5. So that is only 4 over 5x. Okay? So now substitute the value of y. So the value of y is 20 minus 4/5 x. Substitute the value of y in equation number 2 to maximize the area. Substitute in y. So therefore, our equation is the equation that we're going to get the derivative or differentiate is x times the value of y, 20 minus 4/5 x. So let us simplify. So area is equal to distribute x. So distribute 1, 2. So x times 20, we have 20x minus x times 4/5 x, that is equal to 4 over 5 x squared. Okay? So now we're going to tingnan natin. Differentiate, get the derivative with respect to x. So we can just apply the power rule. So the constant and function. So we have derivative of a with respect to x is equal to 20x. So the derivative of 20x is just 20. Derivative of 4 over 5x squared. So use the power rule. So we have minus 4/5. Then derivative of x squared is 2x raised to 1, or simply 2x. Okay, then just simplify. So we have equals 20 minus 4 times 2, so that is 8x over 5, then equate to 0. So equate to 0, solve for x, so equate to 0, solve for x, so therefore we have a denominator of 5, so multiply both sides by the denominator of 5. So we have 5 times 20 minus 8x over 5 equals 0 times 5. So therefore 5 times 20, we have 100 minus 5 divided by 5, that will be cancelled out, that is 1, minus 8x equals 0. Then solve for x. Okay, solve for x, so we have put 8x to the other side so that it will become positive. So add 8x to both sides. So therefore we have 100, so this will be cancelled out, that is 0, equals 8x. So last, divide both sides by 8 to solve for x. So divide both sides by 8. So cancel out. Therefore, the value of x is equal to 100 divided by 8. So we can divide that, or if you want to express in decimal or in fraction, it's okay. If you want decimal, or if you want fraction, you can solve fraction. So 100 divided by 8, that is 100 divided by 2 is 50, divided by 2, 25, divided by 2 is 12.5. So in decimal, that is 12.5 yard. Okay? 12.5 yard. Okay? So the value of x is 12.5 yard. Or if you want in fraction, that is just reduce in lowest term, divide by 4, that is equal to 25 over 2 if you want fraction. Or in decimal, 12.5 yard. Then solve for y. So this is the equation. Solve for y. So substitute 12.5 to get the value of y. Therefore, we have y equals 20 minus 4/5 x. So therefore, y equals 20 minus 4 over 5 times 12.5. So y is equal to 4 times 12.5, that is equal to 4 times 12.5, so that is 50. So 50 divided by 5, so y equals 20 minus 50 divided by 5, that is 10. So therefore, the value of y is 20 minus 10 is 10 yards. Okay? So we want to maximize the area. So this is the value of x and the value of y. So substitute in this equation, area equals xy. So therefore, the maximum area given the condition or the cost of $100. So we have area is equal to xy, area is equal to x. So we have 12.5 times 10 yards. So therefore, the maximum area is 125 square yards. So the final answer is yan. So the maximum area is 125 square yards. Okay? So it's the question. Find the area of the largest lot that can be fenced off for $100. So the largest area of the largest lot is 125 square yards. Okay? So next example, number 7. Okay, number 7. So a rectangular field of fixed area is to be enclosed and divided into 3 lots by parallels to one of the sides. What should be the relative dimensions of the field to make the amount of fencing minimum? So we want to find the amount of fencing, ayan, minimum. So minimum amount of fencing, so therefore we want to minimize the perimeter. So in this example. So let us draw the figure. So rectangular field of fixed area is to be enclosed and divided into 3 lots by parallels to one of the sides. What should be the relative dimensions of the field to make the amount of fencing minimum? So let us draw the rectangular field. So this, for example, this is the rectangular field. So the length is x and the width is y. So we're going to divide this into 3 lots by parallels. So therefore, yan. So we're going to divide this. So we want to find to minimize the amount of fencing that is needed to construct this rectangular field and then divide into 3 lots. Okay, so therefore the total perimeter is, we have 2 lengths and then 4y, so we have 4 y's. So therefore the perimeter, so we want to minimize the amount of fencing that will be used. So perimeter is equal to, so total perimeter is, we have 4y, or unahin natin yung x, so pwede rin naman, so we have 4y plus 2x. So this is the equation that we want to minimize. So the first equation is for the rectangular field of fixed area. Okay, so rectangular field of fixed area. So the other equation is area of this rectangle. The bigger rectangle is area equals xy. So this is our equation number 1, and then equation number 2, the area, the perimeter. So we want to minimize the amount of fencing. So what the question is, what should be the relative dimensions? So we're just looking for the dimensions of x and y. Since there is no given numbers, you just want to solve the equation for x and y. So just like the example number 5, there is no given number, so we just want to come up with the equation that contains y and x. Okay, so let us solve. So minimize the amount of fencing needed. So solve for express equation number 2 in terms of y or x only. So solve for y in equation number 1. So to solve for y, divide both sides of this equation by x. So therefore, y is equal to a over x. So divide both sides of the equation by x. So cancel out. So therefore, y is equal to a over x, and then substitute this. Y is equal to a over x, substitute in equation number 2. So therefore, the perimeter is equal to 4 times y. So we have a over x plus 2x. Therefore, p is equal to 4a over x plus 2x. So, a here is constant. So, number lang yan. So, now, let us differentiate. So, differentiate derivative of p with respect to x is equal to, so, a is constant. So, again, just like in number 5, we have constant over a function of x. So, 4a is constant. Since a is constant, 4 is constant. So, just use the formula for constant over a function is equal to negative of the numerator. We have 4a times derivative of the denominator. Derivative of x with respect to x is 1. All over the denominator square. Okay? Then plus derivative of 2x. So, constant and x. So, derivative is 2. Okay? So, just simplify and then equate to 0. So, we have derivative of p with respect to x is equal to, so we have negative 4a over x squared plus 2, then equate to 0. Then solve for x squared, solve for x or solve for a, since we want to find an equation that contains y and x, so we can solve for a and then substitute that in equation number 1. So either a equals xy or y equals a over x. So let us solve for a. Or another solution is you can solve for x and then substitute in this equation, then try to find the relation of the values of x and y. So mas simple kapag sinolve natin ay a. So papakita ko rin yung dalawang pwedeng maging solution. Okay? So for now, solve for a. So since we have denominator of x squared, multiply both sides of the equation by x squared. So we can remove this. So this is already equal to 0. So we have multiply both sides by x squared. So we have x squared times negative 4a over x squared plus 2 equals 0 times x squared. So x squared times x squared just simply cancel. So we have negative 4a plus 2 times x squared equals 0. Solve for a. So solve for a. So put 4a to the other side so that it will become positive. So add 4a to both sides. Add 4a to both sides. So cancel this. So we have 2x squared is equal to 4a. So now divide both sides of the equation by 4. So divide both sides of the equation by 4. So 4 divided by 4 is 1. So therefore a is equal to, so reduce to lowest term, 2 over 4, so divide both by 2, so that is equal to 1 half x squared. So that is the value of a, and then substitute the value of a in this expression, a equals xy. Okay, so we have area equals xy, so substitute area is equal to 1 half x squared. Okay, so 1 half x squared, so we have 1 half x squared is equal to xy. Then solve for y, divide both sides by x. Okay, so divide both sides by x. So therefore we have x divided by x, so that is equal to y. And then we have x squared in the numerator, so that is 2x. And then x in the denominator, so we can cancel one of the x. So we have y equals 1 half x. So just like in the number 5, y is equal to 1 half x, or y is the width, so therefore the dimension is to minimize the amount of fencing needed to construct this figure is width is equal to 1 half times the length. So this is the dimension. So this is the answer. The width is equal to 1 half of the length. So let's try if we're going to solve for x and y. Then compare natin yung x and y if we have the same answer. So from this equation, so we have negative 4a plus 2x squared equals 0. So let's try to solve for x squared. So add 4a to both sides. So just like this, so we have 2x squared equals 4a. Then solve for x. Solve for x, so divide both sides by 2. So therefore, x squared equals 4 divided by 2 is 2a. And then extract the square root of both sides. So we have x is equal to plus or minus square root of 2a, or since we're looking for length, so there is no negative length, so square root of 2a. So that is the value of x. And then solve for y. Y is equal to a times the value of x is square root of 2a. So simplify. So we have a can be written as square root of a times square root of a. Right? Square root of a times square root of a is a. Then so that we can cancel square root of 2a. Square root of 2, or this can be written as square root of 2 times square root of a. So we can cancel a. So that is the equation. So we have y equals square root of a over 2. So see, parang mahirap yung relation nilang dalawa. So ang y ay square root of a over 2, ang x naman ay square root of 2 over a. So pag kinompare nyo, parang dinivide itong equation na ito, dinivide natin sa 2. Or di ba ang width natin ito, so dinivide sa 2, yung x naman square root of 2a. So parang mas mahirap, mas magulo, di ba? Mas magulo kapag sinolve yung x and y. So ang best na gagawin kapag ganyang hinahanap natin ng dimension, ang best ay isolve yung a. Then after finding the value of a, yung value ng a na 1/2 x squared, isa-substitute natin sa equation number 1. So mas madali siya. 1/2 x is equal to y. So ayan ang equation natin. The width is equal to 1/2 of the length. Mas madali kaysa pag pinag-solve ang x and y, parang mas mahirap i-compare to kasi nagkaroon parang square root. So di ba mas mahirap. So again, best way kapag ganyang problem is yung a ang isa-solve natin instead of x. Since we want a relation of x and y to get the dimension. Okay, so last example, number 8. Okay, last example, number 8. A rectangular lot is bounded at the back by a river. So no fence is needed along the river, and there is to be 24 feet opening in front. So if the fence along the front costs $150 per foot, along sides $1 per foot. Find the dimensions of the largest lot, which can be thus fenced in for $300. Okay, so anong minamaximize natin dito? So ang hinahanap natin sa problem ay find the dimensions of the largest lot. So ibig sabihin, sinosolve natin, ang hinahanap natin ay value ng length and width. So given yung condition natin, so drawing muna natin, rectangular lot is bounded at the back by a river. So drawing natin, so sa likod daw may river. So ito yung river, then ito yung rectangular lot. So pero sabi, no fence is needed along the river, and there is to be a 24 feet opening in front. So let's say this is the 24 feet. Yan, so there is a 24 feet opening in front. If the fence along the front costs $150, so let's say this is the x, including there is 24 feet opening, so this is the x is the length. So the cost for the length is 100 or $1.50. And then for the width, so the width is y, so the cost for the width is only $1. So $1, ayan, so $1, and then for the length, so we have 150, but there is a 24 feet opening. So we want to find the dimension of the largest lot. So largest lot, we want to maximize the area. Find the dimensions of the largest lot, which can be thus fenced in for $300. So $300 budget for the fence. So the perimeter or the total yan total nung fence. So we have fence is y and then plus y, so we have 2y, and then the length is x minus 24 feet because there is a opening of 24 feet. So if this is x, we need to subtract the opening which is 24 feet. Okay, so the length of this is x minus 24. Okay, so this part. This part and then this part. So that is x minus 24. The whole length is x, but there is opening of 24 feet, so therefore, the length of this is x minus 24. Then multiply to the cost. So therefore, the first formula is for the cost, the total cost is $300. So therefore, we have 300 equals, so multiply the side, so we have $1 times y plus another $1 times y. So 1y plus 1y, so therefore that is equal to 2y. Plus, we're going to multiply the length which is x minus 24 because there is a 24 feet opening. Multiply that by the cost which is 1.5. So 1.5 times x minus 24. So this is our equation number 1. So we're going to solve for y in this equation and then we want to maximize the area. So the equation that we're going to differentiate is a equals xy. So this is our equation number 2. So find the dimensions of the largest lot. So we need to solve for x and y. Okay? So let us solve for x and y. So using the two equations, solve for y in the equation number 1 and then after solving for y, substitute it in equation number 2. Okay, so let us solve for y. So solve for y. So, dito na natin ilagay. So we have simplified this, so distribute. So we have 300 equals 2y plus distribute 1.5x minus 1.5 times 24. So that is 24 plus kalahati ng 24 is 12. So that is minus 36. So for y, so combine the constant. So add 36 to both sides. So, okay, so add 36 to both sides. So this will become 336 equals 2y plus 1.5x. Then, so solve for y. So therefore, we have subtract 1.5x to both sides. So therefore, we have 336 minus 1.5x equals 2y. So this will be cancelled out. Then divide both sides by 2. Divide both sides by 2. So cancel out 2. Therefore, y is equal to 336 divided by 2. So that is equal to, let's use a calculator and then 1.5 divided by 2, that is point ano. So ilan ba yan? 336. So 300 is 150 and then 18. So calculator na natin para mabilis. 336 divided by 2. So we have 168 minus 1.5 divided by 2 is equal to 0.75. 0.75x. 168 minus 0.75x equals y. So yan na ang ating isa-substitute. The value of y is 168 minus 0.75x. Substitute natin dito sa y. Okay? So substitute. So we have a equals x times the value of y is, so wala pala tayong denominator, no? So okay. So x times 168 minus 0.75x. So just simplify. A is equal to 168x minus 0.75x squared. Okay, so now get the derivative of this. So differentiate na natin. So derivative of A with respect to x is equal to 168 times x. Derivative of x is 1. So therefore this is only 168 minus, so multiply 2. So we have 0.75 times derivative of x squared. So that is 2x. Okay, so tayo. So we have derivative of A with respect to x equals 168 minus 0.75 times 2, that is 1.5. 1.5x. Then solve for x, equate to 0. So therefore, 168 minus 1.5x equals 0. So put 1.5 to the other side. Add 1.5x to both sides. So therefore, we have 168 equals 1.5x. Then to solve for x, divide both sides by 1.5. So cancel this, that is equal to 1. So therefore, the value of x is 168 divided by 1.5. So we have 112. 112, so ano bang, ano yan? 112 feet. So x is equal to 112 feet. And then solve for y. So this is the equation for y. Ito na lang yung gagamitin natin, yung na-derive na natin. So therefore, y is equal to 168 minus 0.75 times the value of x is 112 feet. So therefore, y equals 168 minus 0.75 times 112 equals 84. Therefore, y equals minus 168. So therefore, is 84 feet. So therefore, ang dimensions na natin ay the dimension of the rectangle to minimize the to maximize the area given the budget is only $300 is 112 feet, the length 112 feet by 84 feet. Okay? So the dimension is 112 feet by 84 feet. So sulat lang natin dito. So yan na yung dimensions ng dimensions is 112 feet by 84 feet, the length and the width. So in order to maximize the area, given the budget for the cost is $300. So given the condition, $1 for each side and $150 for the with an opening of 24 feet. So the dimensions is 112 feet by 84 feet. So that's all for today. So in the next video, we will discuss another topic for maxima and minima. So for part 3, we will solve maxima and minima that involves volume of a cube or rectangular box. Okay, so I hope you learned something. So if you learned something, please like, share, and subscribe. Okay, God bless and bye-bye.